Phase sequence in three-phase system determines the direction of rotation of three-phase induction motor. Phase sequence also decide whether we can connect one three-phase system parallel with another or not. And hence, it is very important to understand what is phase sequence. So, to get the details about phase sequence, watch the video. Winding of a three-phase alternator as shown in this figure, we know that phase difference is 120 degree in three-phase system. Why 120 degree? That because the winding are placed 120 degree apart from each other. So if you would like to have phase difference of 90 degree, just place the winding 90 degree apart from each other. It's all about how you place the windings. Let's say the magnet is rotating in clockwise direction. That means winding Y will reach its peak value first after winding R, and then winding B will have its peak. As you might have guessed correctly, winding Y reached its peak value after the magnet has rotated 120 degree from its initial position. Similarly, when the magnet will rotate 240 degree from its initial position, winding B will reach its peak value. We can also say that waveform of winding Y is leading the waveform of winding B by an angle of 120 degree because winding Y is reaching its peak value before 120 degree of winding B. Or we can say that waveform of winding Y is lagging the waveform of winding R by 120 degree because winding Y is reaching its peak value after 120 degree of winding R. So if you observe the sequence of reaching peak values, you will find that winding R is reaching its peak value first, and then winding Y, and then winding B. And this sequence will continue till the magnet is rotating in clockwise direction. In polyphase system, the order in which a voltage waveform reaches their respective peak values is called as phase sequence. Let's hear it again. In polyphase system, the order in which voltage waveform reaches their respective peak values is called as phase sequence. So, in this case, our phase sequence would be R, Y, B. As R phase reaches its peak value first, and then Y, and then B. Phase sequence can sometimes also be called as phase rotation. So you need not to get confused between phase sequence and rotation, as both are one and the same. Now if I would like to reverse this phase sequence, what should I do? I only need to change the direction of rotation of my magnet. Now we will rotate it in anti-clockwise direction. As we have changed the direction of rotation of magnet, the sequence of reaching the peak values will also change. Now, winding B will reach its peak value first, and then winding Y, and then winding R. So my phase sequence now is B, Y, R. Of course, changing the direction of rotation of magnet is not an option for end user. You can change the phase sequence at your end also, and that is by doing interchanging the phase conductors. So for example, this is your three-phase load, let's say induction motor. If you connect your respective phases in their respective slots, the phase sequence would be R, Y, B. If you want to change the phase sequence, just interchange any of the phases and the phase sequence would also change. Why phase sequence is important for induction motors? Because the direction of rotation of motor can be changed with change in phase sequence. So if your motor is running in opposite direction, phase sequence could be one of the cause. If your three-phase load is purely resistive, then change in phase sequence will not affect anything. But it may affect the unbalanced inductive or capacitive loads. So I hope you have understood what is phase sequence. Do check out the description of this video as I have mentioned some of the video recommendations for you. That's all for this video guys. I'll see you in my next one. But till then, keep watching, keep learning.